Are we live? Okay. So we are live now. Hello, everyone. I'm hoping you guys are doing great. My name is Ashish Jangra. I'm data science mentor at Geeks for Geeks. Hello, everyone. I hope I am audible to you. So this session is specifically dedicated to one of the key faculty that we have here, or key expert that we have here, especially coming from IBM. He's having a diverse experience in the field of data science and AI. When I'm saying diverse experience, I mean to say all the different fields of data science, which includes machine learning, which include deep learning, which includes AI, which include working on text data, we're working on optimizing the algorithms, and also deploying the algorithms, deploying the projects to the client side as well. It's also worked on one of the top companies that you might have heard of. Like he has worked on Tata Steel, Titan, ICICI, PNB. So these are the top companies as a key client. Like he has managed as well. So welcome, Mr. Krishikesh Pathak, sir. Hello, sir.
Yeah, hi. Thanks for that.
So, Rishikesh sir is going to take the session forward by discussing about the different opportunities that you have with IBM, its own portal as well. Like they have their own uh, like portal for data science AIML tasks, where they have end-to-end processes. So Rishikesh sir will take you forward for the career opportunity for the future. And at the end of the session, I also have a special surprise for you, like because we have like done a tie-up with the team of IBM, the intelligent people, where we are coming out with some of the certification with IBM. So I'll take that thing and we'll talk about that thing at the end. So over to you, Rishikesh sir.
Okay. Just give me half a minute. All right.
At the meantime, whosoever is having any question, any doubt like during, if you have any questions, so make sure to add in the chat. At the end of the session, we will discuss about, we'll discuss the answer of those questions as well. So you can mention it in the chats.
Okay. So, okay, just to check again, is my audio clear?
Yes, yes, all good, sir, all good.
Sure. Okay. Thanks for that. Okay. So I don't know if it's audible to you guys or not, but then uh, so I mean, there could be some background noise. There is a concert going on right next to my house. I hope the background noise is not much of a disturbance. Let's see. Yeah, let me know in case there is any issue with my audio, my hearing, or anything like that. Right? All right. Fine then. Okay, so let me share my screen. Okay. So I've shared a screen sharing request. Can you please approve it? Okay. Yeah. Sure. Thank you so much. All right. Okay. Is my screen visible? So, okay, let me just open up a chat window as well in case.
Yes, yes, sir, it is.
Sure. All right. Yeah. Thank you so much. All right. So, yeah, a very good morning, good afternoon, or good evening to each and every participant over here. So, what I understand is, so what I was told by my folks at IBM as well as folks from Geeks for Geeks is that this particular session, uh, it it would be some sort of a, let's say, maybe a beginner level, or maybe up at the most up to an intermediate level session, right? uh, and I was told that I should be focusing in and around topics of, let's say, data science, and maybe to stretch it as well, let's say some aspects of machine learning and AI as well, right? And what I understand is the participants over here, some of you are probably just getting started with your journey in the field of data science ML, right? Some of you may already be doing some tasks around it, maybe some use cases around it, right? Uh, but then, yeah, I'll try to sort of balance the sort of skill levels of all the participants over here. And as we progress, do let me know in case some of the participants wish to sort of go into even more deeper topics of the slides that I'll be presenting, right? So happy to sort of get into any level of detail as we progress, right? Not a problem at all, right? Okay, so let's see. All right. So yeah, I'll skip the slide, but then, yeah, my name is Rishikesh Pathak, and uh, I'll be sort of hopefully taking you through some of these topics around data science, ML, AI. And I've been with IBM for quite a long time now, approximately 10 years, and overall 12 years of experience is what I'll say, right? Uh, yeah, so from a topics perspective, these are the topics which I have planned out for this particular session. So we'll talk about, of course, what is data science. We'll talk about some aspects around what exactly is machine learning, what exactly is AI as well, right? Uh, we'll talk about what does a machine learning model do, uh, how does it work. Again, not in a lot of detail, but maybe at a level 1, level 2 detail as well, right? We'll also talk about some of the algorithms. When we talk about data science, there are some aspects around, let's say, mathematics, statistics, and then we also move towards some of the algorithms as well, right? So we'll talk about some of the algorithms, right? Uh, and slowly, we'll move towards some of the basic use cases as well as some of the industry applications. So when I talk about industry applications, these would be certain applications which either me or my team we have been involved in, we have implemented across certain industries that are quite popular, right? And I mean, although there is a Q&A section at the end of the, uh, I mean, my slides, right? But what I'll encourage is that uh, every few minutes, maybe every 5 to 10 minutes, I will be sort of pausing, and I'm very happy to take any kind of questions which anybody over here has, right? So every 5 to 10 minutes, whenever there is a logical sort of end to a topic, I'll be pausing, and we can take up any questions that we have, right? I believe you do have access to the chat window, so please feel free to put any sort of questions, and I can take them, either myself or the team from Geeks for Geeks. We can definitely take up your questions as well, right? Okay. All right. Uh, okay. So let's start with some terminology over here, right? Okay. Let's check this. All right. Let's start with some terminology over here, right? Now, if any of us does a simple Google search around, let's say, what exactly is data science, what exactly is machine learning, what exactly is AI, right? There's a very good chance that you'll be sort of given uh, a variety of answers. So, if you ask me, uh, each and every different textbook might give a slightly different flavor or a slightly different version of what exactly AI is, or how do you define machine learning, how do you define data science as well, right? But at least what I felt, and what sort of I've tried to sort of put a gist on this particular slide is that uh, it's like a condensed form of whatever I could gather from available sources, right? And this is essentially what we also propose to our own clients as well, uh, regarding the distinction between AI, machine learning, deep learning, and data science as well, right? So let me bring this up. So if I can put it pictorially, right? So at a very high level, uh, we have this umbrella of technology, something called as artificial intelligence, AI for short, right? And what exactly is AI? If I go by the slide, it basically says that it enables computers to perform tasks that normally require human intelligence. Right? Let me just bring up a pen over here. Okay, so as it says, artificial intelligence, essentially what you're trying to do is you're trying to enable a computer, you're trying to make a computer perform tasks that normally require human intelligence, right? So if I give you one example over here, right? So let's say let's say in a bank, right? So whether or not to approve a particular transaction, or whether or not to approve a particular loan application, whether or not you want to uh, figure out how do I sort of categorize my NPAs, how do I uh, uh, I mean, one particular client or one particular account, should it go to, I mean, should it be like a premium customer or some other customer? So these kind of decisions, of course, there are certain rules, there are certain bank policies around it, but uh, is it possible to program a computer, or is it possible to enable a computer to make those decisions of, let's say, uh, approving a trade transaction or approving a loan application, right? If you are able to feed in that knowledge or that capability in a computer, uh, the computer will be able to perform tasks that, let's say, a loan officer would do, or let's say, a savings, maybe a savings officer would do, right? So, at a very high level, artificial intelligence, it includes all those technologies, all those capabilities, which enable a computer to perform human-like tasks, right? Inside it, there's something called as machine learning. So machine learning is, of course, a subset of artificial intelligence. And when we talk about machine learning, let me highlight this particular point over here. So yeah, techniques to learn from historical data. So when we talk about machine learning, the most important thing is that there should be some historical data, and the computer or whatever program you write yet, the computer should be able to learn from historical data. One classic example for this, let's say you have sales data, right? Uh, let's take, I don't know, maybe a Hindustan Unilever company, right? So let's say they have sales data for Surf Excel, or some other, let's say maybe a Dove or a Peers and so on, right? So if they have certain sales data of their products of the, let's say, the last 6 months, they have it till maybe December of 2024. What could be the sales in January 25? What could be the sales in February 25, right? That essentially is how you are learning from historical data, how you are making certain future predictions, so that uh, you can make better business decisions, right? That essentially is the e- entire area of machine learning, right? If I go one level deeper again, that is wherein we enter the area of deep learning. Deep learning, as it says, it is a subset of machine learning. And if I can highlight one particular point over here, it makes use of something called as artificial neural networks. So some of you may be aware of how a neural network looks. There are these neurons, you have these connections between neurons and so on, right? So whenever we talk about deep learning, point number one is that we definitely need to make use of artificial neural networks, right? And point number two, uh, it is, I mean, it usually comes into picture whenever traditional machine learning fails, right? Uh, but yeah, I mean, I'll restrict myself to that for now, for the time being, right? So that's deep learning. And yeah, when you talk about data science, notice how the umbrella of data science sort of cuts across these different domains. So data science, I mean, somebody who is learning data science, he or she definitely needs to know about statistics, mathematics, certain, uh, let's say, visualization techniques, right? And the whole idea of data science is to turn data into insights. So if I can highlight this over here, right? The whole idea of data science is to turn data into insights. What does that mean? You have certain raw data. What information can you get from the raw data which can be beneficial for, let's say, an organization or any other sort of uh, company that you're working for, right? So turning data or raw data into insights is what data science essentially is, right? Another definition that the slide tries to bring up, uh, it can be described as the process of obtaining, transforming, analyzing, and communicating data to answer a question, right? So notice the different phases, if we can put it that way, right? So it is the process of obtaining data, that's part one, transforming data, that's part two, analyzing it, part three, whatever analysis you do, communicating it, right? And finally, the whole intention is to get certain insights to take better decisions, to answer certain questions, right? So, as I said, uh, I mean, the definitions that you have over here may not be very accurate, may not be the most complete definitions. But if you ask me, how can I explain these terminologies at, let's say, a level 0, level 1, right? This kind of definition definitely helps. And this is something which even our clients appreciate, that without going into too much of details, without giving them one paragraph of, or two paragraph of answers, a couple of statements which definitely does the job over here, right? Okay. uh all right, let me just check if there are any queries in the chat window at the moment. Okay, I don't see any queries at the moment. All right, I guess I can continue. Okay. All right, so we spoke about what exactly is AI, right? We spoke about what exactly is machine learning, what exactly is data science, what exactly is deep learning, right? Let me try and go into one level detail over here, right? So when we talk about uh, data science or machine learning, what I mean, you'll very frequently hear this term, something called as a model, right? So I mean, this particular slide, it tries to explain what exactly is a machine learning model, right? Machine learning slash data science model. I'll put it both ways, because at the end of the day, if you ask me, the task of a machine learning model or a data science related model, essentially it boils down to some sort of prediction, predicting some aspect of the future, that uh, future related to the data, right? So one table that you see over here, let me just give me 1 second, let me bring this up. Okay, hold. All right, so one table that you see in front of you, so you have customer ID as one of the columns, you have balance, right? You have a column called monthly savings, you have a column called greater than one account, right? You have a column called account type, and finally you have a column called churn, right? So assume that this is a historical data for a particular financial institution or maybe a bank, right? And the Data, it talks about certain customers. You have certain customer IDs. It talks about certain balance related information. It talks about certain savings of the account, right? On an average, what are the savings? Uh, it talks about whether the particular customer ID, it has only one account or more than one account, right? So there's a very good chance that, let's say, uh, I mean, some of the customers might have a loan account as well as a savings account as well as a credit card account and so on, right? Uh, you also have a column called account type, right? Notice one thing, the account type column, it is encoded. So for example, G could be a savings account, T could be maybe a current account, a corporate account, right? XD could be a credit card account, right? So account type, it is encoded in this particular data. And finally, you have a column called churn, right? I've highlighted over here. Churn is nothing but whether or not this particular customer, is it is this customer still an active customer, or has the customer left the bank uh, because of whatever reason, right? So churn, think of it this way, that whether or not the customer is still a customer of the bank, or whether the customer has left the services, has closed the account, right? So if I take the first row over here, so notice customer ID. So it is 6733 XY 6733. It has a balance of, let's assume, 1000 over here, right? A monthly savings of 25. Greater than one account, yes, right? Account type of G, and notice the churn value, it is Y. Essentially, what we are saying is that this particular customer has churned, has closed the account, and left the services of the bank, right? Let's take one more example. The last row over here, right? So we have customer ID of HH 4455 with a balance of 525, right? Monthly savings of 100. Uh, Greater than one account, no. Account type is XD. This customer, churn is no. Basically means that this customer is still an active customer of the bank, right? I'll repeat that. So the fourth row, what we are saying is the customer has certain details, and churn is equal to no, meaning that the customer is still an active customer of the bank, right? Now, you have certain historical data like this, right? And when you talk about a machine learning model, or when we talk about any sort of a data analysis or any algorithm that we want to apply on this, right? Uh, at a very, very basic level, at a very, very sort of high level, what does a model do? As you can notice, it says model will try and search for common characteristics across all these customers. I'll repeat that. So what the model tries to do is that it searches for common characteristics across all these customers, right? Uh, a simple graph shown over here. Notice that okay, yeah, notice that the values of y and n over here, right? So churn is equal to y plotted in red over here, and churn is equal to no plotted in black over here, right? So this is a graph of churn is equal to y. How does it look? Churn is equal to no. How does it look, right? And one clear cut, I mean, just to put it very simply over here, one clear cut uh, sort of segregation that you see is the blue line on your screen. So notice that there is this blue line, here it is, right? The blue line tries to sort of find certain common characteristics, and it tries to create a separation between churn is equal to y and churn is equal to no. If I can put that in other words, uh, looking at this graph, what you can definitely say is that churn is equal to no customers are more concentrated, or are towards the top right hand side of the graph, right? Top right hand side. Whereas churn is equal to yes are towards at the bottom left hand side of the graph, right? And that's how the blue line tries to segregate these data points, right? So essentially, the model tries to create some sort of a separation like this, so as to figure out that what kind of, I mean, who are the churn customers, who are the active customers, right? That's how you can probably put it. And that's what is represented in the third point over here. So model generates certain rules and patterns that can predict churn, right? So churn is likely when maybe age is greater than 50, or maybe account balance is less than 100, and so on, right? So certain parameters over here. And finally, what we do get is some sort of a table which says these are the set of customers which are at risk of churning out. In other words, these are the set of customers which are at risk of closing their account, right? So net net, uh, when you talk about any kind of a machine learning or data science model, which you will come across in this particular field, the model tries to learn from historical data. Point number two, the model tries to search for certain common patterns, and from these common patterns, it tries to predict, let's say, churn or any other field of interest that you have, right? All right. Okay, let me check if there are any questions at this point. Okay, I don't see any questions. All right, let me continue. Okay, so this was just a quick introduction about what does a model do. Let me proceed with certain algorithms as well, right? So let's let's bring up the table itself, right? Give me 1 second. All right. So from an algorithms perspective, frankly, if you ask me, there are like hundreds and hundreds of algorithms out there, right? Uh, but at least from a level one, level two perspective, what I recommend to our clients as well as to the students as well is that at a very high level, if you are able to master maybe 10 to 15 of the commonly used algorithms, the rest you will be able to figure out, right? And some of the commonly used algorithms is what I've tried to list on this particular slide over here, right? These are some of the most, I mean, very basic and very common algorithms. Uh, and yeah, as you progress in your journey, you will encounter the higher sort of complexity algorithms as well, right? If I sort of break this slide into the different techniques over here. So first and foremost, there's something called as a classification technique. Essentially, what this involves is uh, we are trying to predict group membership, right? So used to predict group membership. Uh, Example, will this customer leave, right? Uh, the example that we have over here, right? So will this customer churn? That is a classification technique, right? Is a banking transaction genuine or fraud? That again is a classification technique, right? Uh, some examples of algorithms over here. So there's something called as a logistic regression, decision trees, support vector machines, and so on, right? I'll not go into the details of these algorithms in this particular session, but yeah, uh, a few algorithms listed: logistic regression, decision trees, and support vector machines as well, right? Uh, Segmentation, used to segment data into groups, or in other words, it is also commonly called as clustering. Uh, so if you have, let's say, customer data, right, and you want to figure out who are my high value customers, who are my low value customers, there are certain segmentation or clustering techniques by which you can create these different segments or different groups, right? Uh, One of the most basic algorithms is something called as k-means when we talk about segmentation or clustering over here, right? The next one, something called as association, right? As the slide says, used to find events that occur together. What does this mean? Uh, So a very simple example or a popular example that is given over here is something called as a market basket analysis, right? Market basket analysis. So for example, uh, if somebody buys bread, there's a very good chance that the person will also buy butter or maybe eggs, right? Or maybe a jam as well, right? So if somebody buys bread, very good chance that the person will also buy butter or maybe eggs and so on, right? So that is an example of association, finding events that occur together, right? One example algorithm shown over here, something called as a priori, right? Uh, and finally, the technique, something called as regression. Regression, essentially what it involves is you're trying to find a relationship between dependent variable and independent variable. Put it simply, these are certain techniques which use certain statistical equations. I like to think of it that way, that uh, usually there are certain mathematical equations, right? And if a particular technique follows a particular mathematical equation, specifically around, let's say, continuous features, right? Continuous variables, then that can be, there's a very good chance it will use the regression technique. One example given over here, something called as linear regression, right? Okay. I think I saw some activity in the chat. Let me quickly check. Uh, okay, I think let me quickly check. Okay, so what I'm guessing is what I sort of looking at the questions that I see, right? Some of these questions will be answered in the next, let's say, 45 minutes of session that I'll be taking, right? So yeah, please keep going with your questions, not a problem. Uh, Anything related to some of the sort of next slides, I'll park it for now. Anything related to slides already covered, I'll definitely answer. And I see one question uh, specifically around algorithm, for example. It says, on what basis do we find the algorithm? So again, there is no single answer to this, but if I give you a broad sort of certain thumb rules or recommendations, right? If you have a categorical feature to predict, categorical output, right? So yes, no kind of an output or something like uh, different classes, right? Then it is more often than not, it will be a classification kind of algorithm, right? If you want to do certain clustering, certain grouping, segmentation is your technique. If you want to find out what pair of events occur together, association is your technique. And if there is a statistical equation involved, specifically around, let's say, continuous variables, uh, there's a very good chance regression can be used, right? That's part one of the answer. Part two, if you ask me, among these techniques, let's say among the classification techniques, which one should I use, right? Uh, Again, there are a lot of sort of checks that need to be done before using a particular technique. Uh, so, for example, let's say a logistic, right? Logistic typically follows, again, there is an equation involved and there are certain sort of assumptions involved as well, right? Related to decision trees as well. There are certain assumptions and so on. For this session, again, as I said, at a level 0, level 1, what I would recommend is that if you are trying to solve a use case, go with some of the easier algorithms first, something like a logistic or a decision tree, right? Go with the easier algorithms first and then experiment with some of the more complicated ones, something like a support vector machine, SVM, or so on and so forth, right? So uh, I hope I was able to answer the algorithm question at least to some extent. A detailed answer, I'll let me know if you need a detailed answer on that as well, or any specific question. Let me know. I can pinpoint and answer that. Right. Uh, okay. The other questions that I see, I'll park it for now. If those questions remain unanswered, let me know. I can get back to it. But I am quite sure that as we progress, you will get your answers to those questions as well. Right. Okay. So yeah, some very basic use cases for data science or ML, right? And when I say that, of course, so uh, every sort of textbook or every sort of, let's say, uh, sort of online material that you have, they will definitely try and sort of bring these use cases in front as well. So the first one that we have, something called as fraud detection. Essentially, what involves is that if there is a, let's say, banking transaction, right? So is the transaction genuine or a fraud transaction, right? That essentially is what fraud detection is all about, right? The next one, product recommendation. This is usually done, I mean, I'm pretty sure most of you would have experience with, let's say, online marketplaces, Amazon or a Flipkart or any other marketplaces, right? And depending on your past purchases or depending on your current browsing history, uh, I mean, the marketplace tries to sort of suggest you or recommend you some more products, right? A very basic example, if I can give you right now. So let's say you want to buy maybe a whiteboard, right? You want to buy a whiteboard. You go to Amazon and you search for a whiteboard, right? Uh, you take a look at the features, what the size of the whiteboard is, and if you scroll down, you will see some sort of a section which says people who have bought a whiteboard have also purchased maybe a duster, maybe a whiteboard marker, maybe a whiteboard stand, or maybe a whiteboard hook, and so on, right? So that essentially is what product recommendation is all about. Uh, Depending on your past history or depending on your current browsing pattern, try and suggest you certain more product recommendations, right? Finding certain patterns or trends. So this you can definitely sort of have a clustering example over here, wherein uh, if you have a sort of mix of customers, then can you segregate those customers or can you find certain patterns or trends to segregate out those different, let's say, customers or any other object of interest, right? Uh, Pricing, yeah. So depending on, let's say, whether or not there is a sale, upcoming sale, or whether or not a particular mobile phone is in high demand, yes, no, right? Depending on that, product pricing decisions can also be taken over here, right? And yeah, last few years, things around, let's say, object detection, autonomous vehicles, uh, drone images, drone footage, and so on. So things around those aspects, image related data, that is also picking up. And of course, as we move forward, you will definitely see more and more of these use cases getting implemented as well, right? Okay. All right. So these were some of the sort of basic use cases, if I can put it that way. Uh, the next section, which I'd like to cover, is that if some of you are trying to implement a particular data science or ML or a AI use case, how do you go about doing that, right? So, of course, knowledge about statistics, mathematics, algorithms, maybe a Python or programming and these things, that is of course required, no doubts about it, right? But from a high level perspective, from a project management perspective as well, right? Uh, you as a data scientist or you as an ML or an AI engineer what are the things that you should do so that your endeavor, your use case becomes successful, right? Next few slide talks about that. And what I'd like to bring about over here is something called as a methodology, something called as CRISP DM. It stands for Cross Industry Standard Process for Data Mining. I'll repeat that. So the full form is Cross Industry Standard Process for Data Mining, also called as CRISP DM. And it is definitely one of the leading methodologies used by data scientists. Uh, Again, I'm not saying this is the only option or this is the only methodology that you should follow, right? But what we have noticed, right? So even in my own engagements and depending on the clients that I have spoken to, right? What we have observed is that even the clients, they do follow some variation of the diagram that you see on your screen, right? Some variation of this methodology itself. What exactly is this method or this methodology? So if I, yeah, if I take you through the diagram, so it starts with a phase called as business understanding, followed by data understanding, data preparation, modeling, evaluation, and finally deployment, right? So first phase, as I said, is around business understanding, right? Data understanding, data preparation, modeling, evaluation, and deployment over here, right? Uh, so think about it this way. So some of you may have heard of this term, something called as KDD, right? Knowledge discovery in databases. This is something very similar to KDD, knowledge discovery in databases, wherein this particular methodology, it takes you through step one, step two, step three of what exactly these steps are, and you as data scientist, what you should be doing in those steps, right? Uh, Let me go one level detail over here. So the first phase or the first step, something called as business understanding, right? Again, you see a lot of text or a lot of sort of things going on this particular slide. I'll not, I mean, I'll keep try to keep things simple. uh, Essentially what this particular phase involves is that you need to figure out what exactly is the business problem you are trying to solve, right? And you need to figure out how, I mean, at a high level, what should be the plan, how should the plan go about, right? So uh, you need to determine what is the business objective, what is the problem statement you're trying to solve, right? What is the success criteria? Do you need a 60% accuracy, or is 80% mandatory, or is 99% mandatory, right? So figuring out the business success criteria, figuring out the, let's say, inventory of resources that you have, right? Be it let's say the number of data scientists, what is the tools that you will be using, and so on, right? Figuring out what is the business terminology. For example, let's say you're working on a telecom data. uh, in telecom there is a KPI, something called as ARPU, right? Average revenue per user, right? So as data scientists, we need to be aware of the, at least some of the terminologies of the business problem that we are trying to solve, right? uh, if it is a banking data set, we need to be aware of what exactly is, let's say, an NPA, right? Non-performing asset. How exactly is the NPA classified, and so on, right? Again, I'm not asking you guys to be the masters of the terminology, but at least at a basic level, we should figure out these terminologies. And if we don't know, ask the business person as well, right? Not a problem, right? So determining the objectives, terminologies, success criteria, and finally some sort of a plan to go about implementing this, right? That's the idea about business understanding over here, right? The next phase, something called as data understanding. Data understanding, as the name says, you are trying to figure out how exactly your data is, right? So first and foremost, you collect your data, You try and describe your data, how many number of rows, how many number of columns, how many continuous columns, how many categorical columns, right? You try and explore your data, figure out if there are certain interesting histograms that you can draw, certain interesting bar charts, or certain interesting scatter plots that you can draw, right? And you also, in the meantime, you also figure out, uh, how good your data is. So, are there any outliers? How many missing values do you have? Is the data good enough for your own use case? Right? That's essentially what you are trying to figure out over here, right? Is the data good enough to address your use case, right? That's phase two. Phase three, as the name says, data preparation. So basically, raw data, you are preparing it and making it ready for an algorithm. I'll repeat that. So when we talk about data preparation, essentially what you're trying to do is that you have certain raw data, you are preparing it, you are transforming it, you are cleaning it to make it suitable, make it ready for a particular algorithm, right? Certain subtasks that you see. So let's say selecting a particular data, maybe sampling, right? Cleaning your data, right? Uh, Constructing new features, something called as derived attributes, right? And any sort of transformations or formatting that is required, right? Again, this will depend on use case to use case, data set to data set. But as data scientists, we need to be sort of inquisitive. We need to be sort of, uh, uh, I mean, we need to imagine what are the different possibilities of formatting data, transforming data to make it suitable for a particular algorithm, right? So that's the phase three. Next phase is wherein something called as modeling, and you try and apply a particular algorithm, use a particular algorithm to create the model, right? So you select the technique. Is it a classification? Is it a regression? Is it a segmentation? Is it an association, and so on, right? Select a particular technique, select a particular algorithm, and finally you build your model over here, right? Once the model is built, the next part is evaluation, wherein you are trying to figure out how good your model is. So, is it giving you an accuracy of 60% right now? Is it giving you an accuracy of 80%? And so on, right? So, evaluate the results, right? Ensuring that the business team or uh, the end user are kept in confidence as well, right? So, evaluate your results, and there's a very good chance that in your first iteration or the second iteration, the results will not be very good. You'll probably achieve maybe 10% accuracy or 50% accuracy, right? So, and hence this particular process, notice that when you evaluate, you can of course go back to one of the previous steps, do some rework, and come back, right? So it is a cyclical process between business understanding to evaluation, and only when you are thoroughly convinced of the evaluation metric, let's say you're happy with maybe 90% accuracy or 95% accuracy, right? Then you can proceed to the deployment side of things, wherein you are deploying it across the organization. You are making the model available to the end users, right? For example, let's say a loan prediction model, right? Uh, Initial testing can be done at the business team level, maybe a central office of a bank, whereas once the deployment is done, that particular model will be made available across all the branches of the bank, right? So branches across, let's say, India or across the world as well, right? So that's essentially what deployment involves, right? So yeah, uh, this particular methodology, crisp DM, one of the most leading methodologies used by data scientists. And more often than not, what you will figure out is that as you proceed in your journey, your own company, or even let's say some of the online tutorials or online, let's say GitHub links, KD Nuggets, Kaggle, etc., right? these notebooks also follow some sort of a methodology, some sort of a pattern that's shown on your screen over here, right? Okay. Okay, let me check if there are any questions till this point. Okay. Yeah, some of the pending questions, I hope they get answered in the next few slides. Otherwise, yeah, feel free to ask me again, and again, I'll more than happy to cover that as well, right? Okay. All right. Now let's talk about some industry applications, right? So hold on, 1 second. Okay. Okay. Yeah. So yeah, let's talk about some industry applications. So uh, the next few slides that you will have on your screen are some of the industry applications. And when I say industry application, these applications are certain implementations which either I have been directly involved in or my team has been directly involved in, right? So you'll notice a wide variety of applications, wide variety of industries. And yeah, I'll try to cover as many sort of different uh, sort of techniques as we speak about them, right? Okay. I can see a few more questions. Thanks for the question. I'll cover a few more slides and then I'll definitely answer these questions. Not a problem, right? Okay. So let's talk about some industry applications. So the first industry application, one company, one of the leading mining companies across the globe. So in this particular mining company, what was happening is that the client was looking for a solution. So the client was looking for a solution which would allow them to move from a reactive asset management to a more predictive approach. What do I mean by that? So when you talk about any sort of a mining company, right? Uh, Picture, I mean, you have these large mines over here there, and in those mines there are a lot of, let's say, trucks like this, right? There are a lot of machinery, a lot of conveyor belts, right? And the whole purpose of a particular mine is to extract certain raw materials, certain resources, and bring it to a particular, let's say, maybe an sort of a steel plant or any other factory over here, right? So one of the leading clients of mining, they were looking for an approach, some sort of a solution, which would allow them to move from a reactive asset management to a more predictive approach. So, for example, let's say a basic example of a truck, right? A sample truck is shown on your slide over here. When we got into this particular engagement, what we realized is that each of these trucks, it has a lot of sensors across its different sort of parts that you have, right? So certain sensors which monitor the tire health, right? Certain sensors around engine, certain sensors around weight of the payload, right? Certain sensors which measure the sort of vibration levels and so on, right? So there were about 150 to 200 different sensors over here. And uh, what the client told us definitely was that if a particular machinery fails, if a particular truck fails, it is usually because some sort of a human error or some sort of a, let's say, prolonged use without any maintenance or without any sort of uh, repairing that goes on, right? So again, I'm putting the problem statement in a very, I mean, in a very basic level at this point, but yeah, a whole host of sensors that we had, and using this data, uh, The client had asked us to figure out uh, at what time will a particular machinery fail. I repeat that. So using these sensors, the sensor data, the client had asked us to figure out at what time will a particular machinery fail, right? Uh, so I mean, we created a whole host of models, right? One of the models, essentially for this particular use case, it used to tell that this particular machinery would require maintenance maybe 2 weeks from now, and if nothing is done in, let's say, the next 2 weeks, there's a very good chance, or maybe there is a 90% chance that in the third week or in the fourth week, the machine might break down, right? So this is at a high level what the uh, model would tell this particular sort of application over here, right? So a more predictive approach is what the client was interested in. And yeah, as you notice in the bottom part of your screen, the blue bar. So the end goal was to have certain early detection of equipment failures, predictive maintenance, right? Predictive maintenance and the scheduling of that, right? And certain asset optimization. So a lot of terminology is thrown over here, but if I can break it down, early detection of equipment failures, that is part one, predictive maintenance and scheduling of that, part two, and asset optimization, that's part three. So this is one sort of end-to-end use case which was done for this particular mining client that we had, right? uh, a slightly more detailed slide over here. So yeah, as it says, certain dashboards and reports were created to understand the health of different assets, be it a truck, be it a conveyor, be it some sort of a stacker, reclaimer, and so on, right? Uh, Machine learning models were created for early detection of equipment failures, right? Uh, and yes, I mean, as I mentioned, right, certain factors such as operating time, was the machine active for 6 hours or was it active for 16 hours at a stretch, and so on, right? So operating time, temperature, pressure conditions, sensor data, and so on, right? And finally, certain scheduling of maintenance operations as well, right? And from a, let's say, techniques perspective, skills perspective, I have intentionally put certain sort of blue boxes on the right hand side. So this particular end-to-end application was developed using Python as the main languages, yes. And we did use skills around data visualization, data science, machine learning, some aspects of AI as well over here, right? Okay. Uh, all right. So this was one application. Uh, I'll briefly talk about the second application and then I'll talk about these questions, right? So yeah, I can see some very detailed and sort of pinpointed questions. Thanks for that. I'll spend some time on these questions as well, man. Uh, yeah, one more application which myself and my team were involved in. So this particular application was for banking, specifically around the trade finance domain. So when we talk about trade, you have these import and export transactions, right? And so for any sort of an import or export transaction, there is basically a currency transaction which happens. So let's say you're sending dollars out of India, maybe, or maybe you're importing something, you're sort of exporting something, then probably you're getting maybe some doll, maybe some money in maybe pound or maybe a euro or a yen and so on, right? So for a particular banking application, trade finance application, uh, the client was looking for a solution to automate the processing of trade transactions, right? So a solution to automate the processing of trade transactions. When we talk about trade transactions, essentially it involves a lot of documents, right? So figuring out, let's say, who is the remitter, who is the beneficiary, uh, who is the beneficiary sort of bank, right? Is it maybe a JP Morgan or maybe a Lloyd's Bank or maybe a Royal Bank of Scotland, right? What is the currency? Is it dollar? Is it yen, right? So reading and understanding 100 plus trade documents and extracting more than 1000 important fields. As I said, so who is the remitter, who is the beneficiary, remitter country, what is the remitter country, what is the beneficiary country, what is the currency, what is the good that is being purchased, what is the invoice amount, what is the address, what is the Swift code, and so on and so forth, right? So figuring out these 1000 plus important fields, and then finally recommend whether the trade transaction is to be approved or rejected. That is the whole sort of goal over here, right? And so what used to happen is that before this application, all of this was a manual task. So a bank officer would manually sort of uh, take a look at these documents, and based on his or her experience and his consultation with seniors, the bank officer would approve a particular trade transaction or decline the trade transaction, right? That is what used to happen. After this solution, uh, what I can definitely say is that the efficiency has gone up at least 2 to 3 times. Uh, if I give you certain numbers, so one particular trade officer who was able to do, let's say, around 60 to 70 transactions in a day is now able to do more than, I mean, about, let's say, 200 transactions a day easily, right? So the solution automates a lot of things. It helps the trade officer figure out if there are any red flags. So, for example, you can't send money to buy AK-47, right, or any sort of a machine weapon unless you are a government entity, right? Or if you are buying gold, you can buy gold in certain restricted amounts, but you can't buy a large amount of gold or maybe a crude oil, right? So the solution would sort of highlight these red flags if there are, and it definitely help the trade officer to sort of improve his or her efficiency over here, right? So yeah, that's another sort of industry application which is giving very good results at the moment, right? All right. Okay. So, all right. Yeah. So, as the sort of takeaway blue box that you see, an end-to-end solution for processing trade documents and recommending trade approval or rejection over here. That is one sort of industry application which me and my team were definitely involved in, right? Okay. Okay. So, let me just check the time. We are at 8 o'clock over here. Okay. So what I'll do is I'll take up some of the questions at this point, and then I'll come back to some more industry applications, right? Why not? Let me just check this. Okay. So I have a question which says, I'm starting as an SQL and BI developer. All right. What is the scope for me in current market as an SQL developer? Okay. So when you talk about an SQL developer, frankly, if you ask me, uh, SQL is definitely in scope and will remain in scope no matter what, right? So when you talk about, let's say, a data engineer, or I mean, the initial roles are called as data engineer or an SQL developer, right? So as an, if I mean, if you're able to master SQL, that is definitely one good skill to have. And something like a data engineer is definitely available out there to sort of apply for and get the job as well, right? However, having said that, please also note that so as we are as I'm speaking, right, so it's like 2025 right now, right? So uh, the market already has a lot of SQL developers, right? So although there are a lot of positions in, I mean, across companies, uh, you may need to be certain, I mean, you may need to sort of figure out which exactly company you want to apply for. And the competition will not be easy. So I mean, there is competition in the SQL developer field, because again, these are like traditional roles which have been existing for a very long time now, right? uh, Okay, let me check the next question. Okay, so okay, hold on. So, okay, I have an interesting question. Does fresher need to learn data science, data structures nowadays as AI are able to solve such problems, right? Uh, okay, how do I answer this? So, see, the thing is, in 2025, right? There has been an explosion of these large language models, LLMs, ChatGPT, and these things, no doubt about it, right? Uh, can AI solve some of these use cases? Yes, but can it can it replace a human being? No, right? So if you ask me, let's say for any use case, right? Uh, maybe 2 years back, if it required, let's say, four data scientists or three data scientists for a particular use case, right? Today, there's a very good chance that probably one data scientist can accomplish it, right? Taking the help of AI. So, what I can definitely say is that AI, LLMs, can it completely replace a human being? No. Can it completely replace a data scientist? No. But it will definitely sort of enable existing data scientists, or it'll increase the efficiency of the data scientists in a particular organization. No doubt about it, right? And yeah, one more sort of a side note which I can definitely say is that even today, right, uh, companies are scared to completely rely on AI generated outputs, right? So an LLM or an AI output, if it generates something, okay, but companies don't, I mean, they can't blindly trust it, right? You need a human presence, you need a human intervention, or maybe human verification to ensure that AI is giving you good outputs. So that will obviously be, I mean, it will definitely remain. So I don't think that is going anywhere, right? uh, I hope that answers the question. Let me know, if not, let me know. Yeah. um, so I have a question again. I'm learning data science, machine learning, generative AI. Okay. My Should we focus on the topics that can be asked? Okay, so okay, this question is more about focusing on what topics for interview purpose, right? What I'll recommend is uh, understand the position that you are trying to sort of apply for, right? So if the position explicitly asks you for experience in AI, experience in LLMs, then at least for that particular interview, your focus or your way of answering can be more towards LLM side of things, right? Whereas if the position is more from a, let's say, a broad level data science role, right? A broad level data scientist role, then probably you can prepare accordingly, right? So, I mean, I mean, at this point, we can't say this topic or that topic, right? I mean, as you guys would already know, uh, I mean, there is immense competition last couple of years in the role of data scientist, AI, ML engineer as well. We need to be prepared irrespective of what opportunity comes, right? What role comes, right? And but yeah, depending on the job opening, you can fine tune your answers. You can fine tune your CV to suit what the interviewer is looking for. Yeah, I'll repeat that. So depending on the job opening, depending on the job description that you get, you can probably fine tune your CV. You can probably fine tune your answers to suit what the interviewer is looking for, right? So if the interviewer is more focused on LLMs, your CV, your way of answering can be slightly tilted towards that. But if the interviewer is looking for a traditional data scientist role, you can modify those answers accordingly, right? I hope that answers the question. Let me know if not. Um, okay, let me check again. Okay, let me just, so this is consuming. I'm just stopping my video for the next 5 minutes. It is sort of interfering in the answers. Hold on. So, Let me minimize this. I'll just expand the chat window for the time being. Mm. So, okay, I have a question. How can we build projects to hone skills required for practical aspects? Okay, so uh, again, now uh, working on, okay, okay. I mean, to answer your question, it depends on whether or not you are, uh, I mean, you are, let's say, doing your engineering, you are in your studying phase right now, or are you actually uh, working right now, right? So I'll try and answer both ways, right? Let's assume you are a working professional, right? So if you are a working professional, you may or may not be from a data science team, right? You may or may not be working with data sort of continuously. That's okay. But what I've seen is that if you're a working professional, you can definitely try and maybe convince, let's say, your manager of what data can do to your team, right? And accordingly, you can sort of build incrementally to uh, deliver use cases, firstly focusing on your team, your business, and then maybe expanding to other teams, right? So one example which one of my colleagues had, sort of one of my friends had done. So he was working for a bank, right? He was not part of the data science team as such, but then, so he was part of the trade team, trade transactions team, right? So initially what he did is that he used to do certain analysis of trade transactions using Excel. Slowly he went into Python, right? uh, Again, he was not a very experienced, of course, data scientist, but slowly when he sort of gained his skills, when he was able to convince his managers about the benefits of the analysis, uh, he was able to transition from a trade officer to a data scientist kind of a role, right? I hope that kind of answers that question from a working professional perspective. If you are a student, what I'll recommend at this point is that take a look at some of the freely available data sets, right? Publicly available data sets. And uh, over there, the skill actually lies in how do I make the best use of my skills, my techniques, my algorithms to bring the best from whatever data that I have, right? So a publicly available data set, you will find a lot of GitHub links, you will find a lot of publicly available code as well, right? Uh, you need to sort of pick and choose. Uh, I mean, level one kind of a project, mini project, level two kind of a mini project, level three kind of a mini project, and so on, and accordingly add it to your CV, right? Uh, I hope that kind of answers the question. Let me know if there is, I mean, you want me to discuss some more details, or if there is another sort of deeper question over here, right? So yeah, that was a question from Utkarsh, I believe. Yeah. Uh, I already answered the question from yeah, this question already answered. Okay, let's okay. Okay, yeah. Thanks a lot for the questions. Yeah, let me take these one by one. All right. So I have a question from Sai Kumar. I heard these data roles varies from company to company, and there will be large variability while getting into another company data job. Okay. Uh, okay. So yes. So what you will definitely notice is that each company would have their own designations. So some might say, some might call it a data scientist, some might call it a AI engineer, some might call it a ML engineer, some might just call it a finance analyst, an HR analyst, or an operations analyst, and so on, right? So you will notice a sort of different designations, right? But at the end of the day, if you ask me, uh, if you are in a particular industry, the use cases remain the same. For example, if you are in a bank, right, the typical use cases for a bank would remain the same for an ICICI or a State Bank or an HDFC or any other bank out there, right? So, uh, what I tell my students is that focus on, let's say, these techniques, focus on the use case, right? uh, Once you get a hang of it, even switching between companies will not, I mean, you'll not be completely alienated, or you'll not feel as if you're totally entering into a different domain, right? So yeah, focus on the use case, because at the end of the day, for a particular industry, use cases tend to remain the same, right? I hope that answers the question. Let me know if there are any more questions to that, right? Okay, I have another question from Rekha over here. Okay, data scientists should be aware of business. Okay, so what I meant by that is that you need not be experts in the business, but you should at least be aware of what the data is trying to tell you. And when I say that, you should be aware of what are the different columns. uh, what does, let's say, business terminology mean? What does a non-performing asset NPA mean? What does an ARPU, average revenue per user, mean, and so on? So at least from a level 0, level 1 perspective, a data scientist needs to get in touch with the business team and understand the business, at least at a level 0, level 1 perspective, right? I hope that is clear. Okay, I have another question from Atul over here. Okay, let me check. So the question is, creating models and deployment, is it handled by the same data scientist? It depends. As of today, let's say 2025, some of the mature companies, right? Some of the larger companies have a separate team for model development, and they have a separate team for model deployment, right? But if you enter, let's say, some of the, maybe a startup, right, or maybe some of the not so mature companies, right, there's a very good chance that the same data scientist would be required to develop the model and deploy the same, right? So yeah, that's how it is. And but yeah, one thing is definitely sure, that as time goes on, right, many more and more companies are becoming mature from analytics, data science, ML, AI perspective, and slowly you will notice that uh, there, I mean, companies prefer a separate team for development, model development, and a separate team for deployment, right? uh, okay, so that was part one of the question. Part two, what I see is, explain more about the model accuracy. So what I meant by accuracy, I'm not sure. uh, Sorry, so what I meant is basically, uh, when you are creating a model, uh, how accurate the model is, right? Is it giving you a 60% accuracy, 80% accuracy, 99% accuracy, uh, and so on, right? And for every technique, so classification models have their own evaluation metrics, accuracy metrics. Regression models have their own evaluation metrics, right? Association, segmentation models have their own evaluation or accuracy metrics. So depending on the algorithm, depending on the technique, you will have to figure out what evaluation metric suits my use case, right? I hope that answers the question. Let me know if there are any more details required. Okay, I have a next question from Tejas over here. Let me check this. Okay, the trade data set. No, no, it's not a publicly available data set. So the example that I gave was proprietary for a particular bank. So it's not a publicly available data set. Yeah. So, but yeah, I mean, if I mean, I don't know if there may or may not be any publicly available. So, but the example that I gave on the slide was proprietary. It was confidential for a particular bank. Yeah. Uh, okay, I have another question. So let's see. Some examples of project which we can have as freshers. Okay. Okay, let me bring this up then. So thanks for asking this. Let me stop my PPT. Let's see. Uh, let's see. Okay, I'll just add a new slide for the time being. Okay, maybe I'll add it towards the end. Okay, let's have this. Okay, so I'll just put out some of these projects, mainly from a fresher's perspective, right? Somebody who is just getting started in his or her journey uh, in data science or ML, right? So let's me, uh, okay, let me just have it this way. So what I would recommend is that you try and get certain expertise. Okay, okay, hold on. Experience across techniques. Let me just format this a bit. Okay. Yeah. So what I would recommend for all the freshers out there, or somebody who is just getting started in their data science ML journey, is try and get certain expertise, try and get certain projects under your belt, uh, which are across techniques. What do I mean by that? So, for example, uh, let's see. So have one project for, let's say, classic. So yeah. So maybe a project on classification, a project on regression. Uh, in the classification kind of a project, you can try and incorporate some aspects of clustering, segmentation, right? Regression would be a separate project altogether, right? And if time permits, if your skills, rather, if you are willing to experiment even beyond this, then try and have a project on deep learning, right? When we talk about deep learning, again, if time permits, if you have the sort of inclination, then try and have some project around images, right? So I mean, if any interviewer takes a look at your CV and the interviewer realizes that, let's say, uh, you have a project done on, let's say, classification, which is the traditional data science or ML technique, right? You have a project done on regression, and you have a project done on deep learning, images related, right? Uh, I mean, this would really be a kind of a complete CV if you ask me, for a fresher, right? Again, deep learning, I leave it as optional. It depends on the role that you're trying to apply for, right? Some companies, I mean, even at 2025, many of these companies still stick to traditional approaches. So that is the first two techniques. Uh, some of them have moved on to deep learning, AI, LLMs as well, right? So, but then yeah, if you are able to get certain projects in these techniques, very good, right? And if, again, problem statement is something that you, I mean, just try to figure out, right? But then from an algorithms perspective, try to incorporate algorithms such as, let's maybe logistic regression, decision trees, right? You can have maybe a basic neural network over here as well, and if required, SVM as well, right? So if you're able to have some classification project done using these algorithms, that's definitely a very good plus point, right? When you talk about regression, try and incorporate algorithms such as, of course, linear regression, and there are sort of higher order regressions. So let's say a polynomial regression as well, right? And from a deep learning perspective, uh, when you talk about images, right? Uh, I mean, try to have certain sort of use case or certain projects around something called as CNN, right? So that's like convolutional neural networks. Uh, if you are willing to experiment even more, then some project on maybe NLP, speech uh, related, right? So that can use maybe an RNN or LSTM architecture. So yeah, this is some of these sort of topics which I can recommend, definitely recommend for a from a fresher perspective, right? I hope that answers the question over here. Uh, okay, I have another question. Okay, let's check this. So electrical engineering, all right. Okay, okay, data science, all right. Okay. So what I mean, the question that I have in front of me, right? So the gentleman over here uh, uh, is primarily from an electrical engineering background, all right, and now interested in switching to a data science kind of a role, right? So what I'll recommend you, sir, is that try and have certain projects under your belt, be it fictitious data, whatever, publicly available data. If you can have certain projects belonging to your domain, electrical engineering kind of a domain, that will definitely help. Frankly, if you ask me, in India, right, or across even the world as well, some of the clients that we have been interacting with. So, uh, many clients who are in the manufacturing domain, in the electrical engineering kind of domain, there is still a I mean, there is still a shortage of good data scientists in manufacturing and electrical kind of domains, right? So if you can get certain exposure, uh, certain publicly available data, or if you have your own company data available, trying to create certain models out of it, doing certain predictions, that can definitely help. So you have a past experience, and that can help in the sort of your switch to a data scientist role as well, right? Uh, I think, yeah, let me know if you have any more questions over there. Uh, okay, one question from Ayush again. What impact do you think AI will have on software engineers? So this is something that I tried to answer earlier. So as I said, uh, AI, LLMs, ChatGPT, Microsoft Copilot, GitHub Copilot, and so on, it will definitely, I mean, it definitely enables data scientists, software engineers to do faster work, right? And one thing that I definitely see happening is that a particular use case, if it took maybe three data scientists, uh, maybe 2 3 months of effort, that can be replaced by one data scientist. So yeah, frankly, I mean, if you ask me, anybody out there who is a software engineer in the IT domain, one thing that is certain is that change is happening, change is even inevitable. We need to keep upskilling ourselves. Uh, that's the only option. If I mean, remaining stagnant is not an option if you are in the IT space or the data science space, I guess, right? Yeah. Okay. All right. Let's take the next question. Uh, on what particular skill should one focus on to get into? Okay. So from a skills perspective, uh, again, as we kind of slightly discussed, right? Try and get skills around these topics. For example, let me bring this up again. So the slide that you have on your screen, right? So definitely skills around Python, skills around data visualization, data science, ML, AI. Uh, skills around this technology is definitely required, and the best way to demonstrate these skills is to apply it in some or the other project, be it a real life data set, be it a fictional data set that you pick up in Kaggle. And at the end of the day, when it comes to interviews, you should be able to fully justify to the interviewer that you are aware of what project you have done. Uh, the interviewer may ask you questions in depth, and you should be able to sort of answer these questions in depth as well, right? Uh, yeah, I hope that answers the question. Let me know if you need any more details. Okay. Okay, I have a question from Aniket. Is there a better option to choose data science as freshers? Uh, I'm assuming the question means, is data science a good option? Right? For freshers, right? I'm assuming the question means that. So yeah, for everybody out there who is a fresher, uh, if you are getting a role of a data scientist, doesn't matter what the company is, right? So if you're able to get a role as a data scientist, yeah, I mean, you can definitely go for it. Uh, you would be tested. I mean, you would require skills in programming, mathematics, statistics. At the end of the day, data analysis is what you'll be doing. Uh, and again, so there's something which I tell some of my students, even if you don't get a good package right at the start, right, as a fresher. So something that I've heard in some of my sessions, right, some of my face-to-face sessions. So some of these students, I mean, I'm not trying to sort of demotivate anyone over here, but some of the students, they say that we need a package of 15 lakhs per annum, 20 lakhs per annum right at the start as a fresher. And my response is, if you get it, very good, congratulations, do your best. But if you don't get it, if you're getting a package of, let's say, maybe a 4 lakh or a 5 lakh, or even if it's a 2 lakh package, doesn't matter, right? My my recommendation is, get started, get going, slowly the package will increase, right? With experience, 2 years, 3 years, 5 years, the package will definitely increase, should not be a problem, right? Okay. Let's see. Roadmap for freshers. Yeah. So get as many projects as possible. The list of projects is something that you can take. Okay, let me bring this up. Yeah, the list of projects. I mean, a draft slide that I have. So list of projects that you can pick up, right? Problem statement. Try and figure out from yourself, right? I mean, there is a lot of publicly available material out there. So focus on some of these techniques in your projects. And from a skills perspective, yeah, you can focus on the skills on the right hand side that you have. So Python is, I would say, is a must. Skills around data science, ML, AI, algorithms, and so on, right? Uh, okay. Yeah, couple of questions around timing. I mean, yeah, to be very honest, the timing is flexible, and that's why uh, there's no hard and fast timing as such, if you ask me. Yeah. Okay. All right. I'll take the next question. So, project around image enhancement of lunar craters. Okay. So, when you talk about, okay, if I understand this right, the project that you're suggesting is around image enhancement. Uh, so, image enhancement, yeah, why not? So, that I mean, if again, uh, if you can go beyond image enhancements as well. So, let's say some sort of object detection, right? So if you can go a level deeper on that, that will definitely add to your resume as well. So image enhancement would be like maybe the step two, step one, step two, step three, but a step four, step five could be like object detection, detecting any anomalies in the crater size, any foreign objects, and so on. That will definitely add to the problem statement that you have, right? Okay. Uh, yeah. So image enhancements would be like step one, step two, step three. any sort of object detection, anomaly detection, you may consider it as well, right? Why not? Okay. Uh, Let me check if there are any more questions. Okay, I don't see any further questions in chat at least. Uh, okay. So, I guess, yeah, Ashish sir or Vineet sir, any more questions that you see in chat which we'd like to take up?
Uh, no, sir, that is it.
Okay.
Like we are done with most of the question. There are some question, but they are relatedly almost like almost the similar as someone else has asked and you
Sure.
mentioned. Like almost all of them are done.
Okay. Okay. All right. So, yeah, I think from a at least my presentation perspective as well. So I was sort of approaching the end of that. Let me quickly check. So, I mean, yeah, so I'll not talk about all these use cases, but the whole point of this particular slide, what I wanted to convey is that at least, uh, be it India, be it across the world, data science, ML, AI is gaining traction. Uh, a lot of roles that are coming up, and with some of the questions that I see, the advent of chat gpt llms, right, more and more companies are tilting their focus, shifting their focus on these data science, ml, ai technologies, right, across India, across the world, right. So, again, we need to constantly keep upskilling. That is one part of it. But the if your skills are relevant, you will definitely find very, very good job opportunities, is what I can definitely say, right. uh, yeah, so strong push towards these technologies, and uh, across designations, be it a data scientist, ml engineer, business analyst, data analyst, or any of the management roles as well, right. So even the management roles today, uh, managers are interested in figuring out how data science works, or how AI works, or how AI can help my business to increase, my sales to increase, and so on, right? So, technologies and skills around this, at least if you ask me, will remain relevant for the next 5 to 10 years. Definitely should not be a problem, right? Okay. Uh, so I guess, yeah, that's it from my side. Ashish sir, Vineet sir, yeah, back to you, I guess. Yeah.
Okay, thank you so much, Rishikesh sir, for giving your valuable time to the students and asking uh, and also answering the question to the students. There are a couple of question if they are asked right now or probably the future. I'll be answering it right there.
Sure.
So all of you guys, like you guys can connect to Rishikesh sir over LinkedIn. So you can search on them on internet. So you'll find them. And yes, thank you so much, Rishikesh sir, for joining in. So now I'll take the session further with okay, I have one or two questions I'll answer. So the first question is SQL really important for data science? Yes. Be it data science, be it data analytics, SQL is one of the core skills that you need to have a part in. So make sure that you have an account on. Uh, Means you are pretty good on SQL. And Rishikesh sir, if you can please share your LinkedIn account here so that I can share with the students as well, it would be great.
I'll put the link in chat. Yeah.
Yeah, sure. Thank you. So, and there is one more question. What will be the essential language for? I'm really sorry again for taking you for make you waiting for so long. So, what is the essential language for the time limit to complete DSA? So, if your agenda is to go to data analytics or data science, so the go-to language you need to go further is definitely Python. So, Python is something you need to go ahead. Okay. So okay, so if anyone has any further question, do let me know. I'll have a last walkthrough at the end of the session as well. Okay, so now I have some special announcement for you guys. That's of our like premium thing that we are currently doing of 390 challenge. Okay, so I have couple of things that would like to discuss with you as a promise, that at the end of the session I will be discussing about it. So here, as you can see on my screen, I hope the screen is visible to you. So currently we are running a lot of things. So let's start with the first thing, which is the 390 challenge. So a lot of you might be already aware about the 390 challenge. If not, 390 challenge is, as the name suggests, three is not 390s, 390s. So it goes like 390s. It goes something like this. Okay. So basically, what 390 is, there we have 390s where you will get 90% of the money back if you complete 90% of the course in 90 days. So it will make you consistent, and at the end of the course, you have like, so we are basically giving you refund if you are consistent on the course. That's what we are doing. So for that purpose, like what, and that's something that's available in almost all of the courses that GFG offers. What you can do, go to the GFG website, go to courses, go to all the courses, and here you can see you have an offer, you have an like option of avail the refund. So this is what we have written. So these are all the courses where you can avail the refund of 90%. Okay, so here we have the course of DSA, backend, machine learning, data science, data analytics as well. And if you I go specific to data analytics or data science module, where you can like I can go here, data science and machine learning. So here you can see we have different courses of data analytics, data science. Some of the courses are hybrid. Some of the courses are offline, where you can come to the class and in the classrooms of different locations. We have different classrooms. We have in Noida, we have in like Bangalore, we have in Hyderabad launching. So you can go and take the offline classes, and then all, and also online live classes. So these are some of the data analytics courses that we are currently running. So you guys can go through it. Like this is the free one that we have, data analytics bootcamp. There's also one of them where like where you can have a participation and see how the things are going over for you. Okay, so so these are the list of courses where you can go ahead. Okay, so and you can get 90% of the money back if you complete 90% of the course in 90 days. 90% of the course completion means you need to, you know, complete the video, complete the assignment, and it's a dynamic module, so it can be easily achievable, and it will make you consistent as well. So this is part one of the thing that I want to discuss. Second is, there are also a couple of courses where we have associated with IBM. As you can see, IBM is written here, like we have the icons of IBM. Okay, so in these courses we have also associated with IBM. Okay, so in these courses, if you go to these courses, for example, if I go for this one, data science training program. Okay, so here you can see in the data science training program, so it's a 10-week program where we'll start from basics of Python, like and will take you to data analytics, work on different libraries, tools used for data analytics, and take you further to machine learning, deep learning, and so on. Okay, and in this courses, now these courses which are like where we have typed up with IBM are really special, because here you don't only get the content that is created by Geeks for Geeks, you are also getting a separate course, a separate certification from IBM. So you will get a certificate from Geeks for Geeks as well as IBM. Okay. But like the 390 challenge that we are currently running, where you will get 90% of the refund back. So this 90% of the refund will not be applicable on this particular amount that you are paying for the IBM certificate. So there is a default course that we have of data analytics, of data science, and on top of that, you can also avail for the IBM certification exam. So in the IBM certification exam, you can get a lot of perks along with the dedicated modules of by IBM and the recorded as well. And not only that, you will get like quarterly sessions, and no, and also the exam. So there will be a exam specifically conducted on IBM's own portal, and based on their criteria, you like if you fulfill that criteria, then only you will get the certificate. Okay. One very important thing is 390 refund uh, will not be applicable to this amount if you are paying it. Okay, but it will be applicable to the to the base course that you are offering. So we have a base course of data analytics, data science, machine learning, and on top of that, you can also avail for the IBM certification, which comes with IBM their own curriculum, along with existing data science geeks for geeks, and on top of that, you also have a dedicated exam. Okay, so this is something that we are coming up with the association of IBM. So you will get certified if you are taking part of IBM, not only with Geeks for Geeks, but also with IBM. Okay. Uh, one like this is how the whole scenario works. Okay. Now, I also have a very special announcement for you, a special offer for you basically, and that is of giving you a coupon code. Okay. Now, the coupon code is something I'm going to share it with you in a minute. But at the meantime, if you guys have any question, do let me know. I will be sharing the coupon code with you within a minute. Okay. Mhm. So if you guys have any question, do let me know. And let me go through the chats. If you guys have any, how much SQL is needed? Okay, so that depends. For a fresher, if I'm talking about like SQL, if you know the basics, the fundamentals of SQL, that is enough. Okay, so fundamentals of SQL means what is the use of databases, what are the applications of it, how you'll go for all the DDL, DML commands, how do you can work on joins. Not only joins, you need to know about the aggregation function, the group by function, the window function, sorting, getting the data, and also some optimization techniques through which you can optimize your existing queries. Okay, this is the core of SQL. Okay, once you know SQL, then based on different companies, based on different organization, they might be using different kind of SQL based databases. Okay, then there will be some separate thing that are there company to company. Okay, but the fundamental remain the same. It's same like the ABC of SQL will remain the same. Okay, but only some minor changes will be there. So I have like told you a couple of topics which you guys can go through for sure. Okay, so how can be play of this course as IBM course? How can IBM employee after the project? Okay, I don't understand the question. Like share, how can I be employee? I don't understand the question. If you can rephrase it, that would be better. Okay. So not only that, there's okay, now I think this is the time to share with you the coupon code. So I'm sharing with you a coupon code exactly right in the chats. Okay. So the coupon code is decode data. Okay. So I'm mentioning it in the chats as well. So if you go to the course and go for this particular coupon code, let me present my screen with you again. So the coupon code is decode data. Okay. So that's the coupon code that you can apply, decode data on like while registering or doing the payment or doing the registration, and you will get some extra discount on the course as well. So make sure to go for that. Make sure to go for the coupon code to save some extra bucks. And that is basically it. If you have any question, if not right now, but probably in the future, you can also like connect with us on LinkedIn. Okay, so I sure if Rishikesh sir has shared their LinkedIn here or not. Rishikesh sir, like have you shared your LinkedIn ID, sir, in the chats? Rishikesh sir is here. Okay, okay, sir has
Yeah, I
shared.
have shared it. Yeah.
Okay, okay, thank you so much. So I'm sharing the exact same thing uh, for the students joined online as well. Okay, so I shared the LinkedIn as well, so you guys can definitely have a look to the, Rishikesh LinkedIn. And not only that, if you want to connect with me on LinkedIn, so you can do that as well. So let me share that as well. Mm, 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 mm. So this is my LinkedIn. If you guys, if not right now, probably have a question in the future, you guys can connect with me over there anytime. Okay, so I'm sharing the coupon code again. Decode data. Okay, so decode data is the coupon code that you guys need to go through. Okay, and I'm also sharing my LinkedIn right here. I've shared it here. Okay, how much math is needed for data science or data analytics? So for data analytics, the maths needed would be statistics and probability. Okay, these are the two main things that are required. If I'm talking about data science, so on top of the probability and statistics, algebra and calculus are needed, because these are some of the fundamental things that you have. If you want to dig deeper, as like Rishikesh sir has also mentioned, you need to know the fundamentals of some of the programming language, not the programming language, but fundamental of some of the machine learning algorithms, the fundamental algorithm. For example, linear regression. Okay, you can write the code using some inbuilt library for in just one line of code. You can execute it to run linear regression. But the funda is to know the working behind it. You need to know the maths. You need to know how to write these algorithms from scratch. Okay, so if you want to really call yourself a data scientist, definitely at after one level you need to use some inbuilt libraries to get the things done. You are not going to write all the things from scratch, but the funda is you need to know the fundamentals. Okay, because it's same like if you want to call yourself like you are engineer of a car. So it's not like you need to know like how to do some of the tweaks in the engine to get better performance. You need to know the underlying hardware of the car, right? How the engine works, how the friction works, how car works, how motor works. Okay, so for some of the basic algorithm, you need to have the fundamental knowledge, the working behind it, and math is something that's somewhat needed, and algebra and calculus and the two things. So probability stats for analytics, and algebra and calculus for data science. Okay. Okay, so to give you a quick roadmap of data science. Okay, so quick roadmap of data science will go something like this. Start from Python. Okay, and in the Python, go for some of the basic functionalities of Python, core Python. Okay, I think I might share you some resources. Okay, just give me a second. Let me present my screen with you. It might help you a little bit in this. So if I talk about, so here you can see in the GitHub you can get a lot of resources for data analytics and data science. Okay, so for data analytics, I think okay, these are the sources of data analytics, and then the exact same way you can also get it for data science. And if I talk about, okay, let's suppose if I'm talking about data analytics. Mm, 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 mm. Where was that? Okay. So here you can see in the data analytics, these are some of the things that you need to know. Like these are properly arranged like structure wise, where we are starting with pandas and everything. But these are the data analytics you need to know after knowing the core Python. Okay. So to give you a brief, if I'm talking about, start with Python, go for how to write the logic, how to basically code anything. Okay. So once you know how to code, which include condition, which includes operators, which includes loops, which includes data structures, specifically list and dictionaries. You need to master these two things, because if you have mastered list, it resembles itself to a structured database. Okay, if you have mastered dictionary, it resembles itself to no struct unstructured or no SQL based databases. Okay, so if you have mastered multi-dimensional list and dictionary and multi-dimensional dictionary, it would be really easy for you to work ahead in databases and working even further with data. Okay, so this is basically the core Python. You can go back anytime and go through the video uh, to get back anything that you want. Once that part is done, then jump on libraries, which is Python, which is NumPy, which is Pandas, which is Matplotlib, Seaborn Plotly. These are for visualization. Some of them are for data cleaning, data handling, EDA, data analysis, data visualization. So this is how the roadmap of data analytics looks. But for a data analyst, you also need to know the tools like Excel, the tools like SQL, the tools like Power BI or Tableau. But if you want to dig deeper into data science, so once your data analytics is done, jump on the machine learning side, which requires the feature engineering, which requires transforming the data so that machine learning algorithms can ingest it. Uh, and what are machine learning algorithms? What are different algorithms do we have? Okay, you need to know the fundamentals, the working behind them, how to write the algorithm from scratch. For some of the algorithm you need to know that logic as well, but once that part is done, you can anytime go ahead and work on the advanced algorithm, like how algorithm can be performed. MN algorithm can be performed for classification based tasks, for regression based tasks, for unsupervised learning tasks, for working on text data, for working on financial data. Okay, and this is how the roadmap looks. And as the time pass by, you can also jump onto the deep learning, which include artificial neural networks, which include different architectures like ANN, CNN, RNNs, and come to the point of as transformers. And then you can take this session, take a step forward and take you to the generative AI as well. Okay, so this is basically a quick walkthrough of how the whole process, how the whole walkthrough goes. Okay, anytime you can go to the GitHub, and as well you can get a lot of resources of machine learning, of deep learning, of interview questions. Like recently we have made this interview question as well, where you have a lot of practice question of machine learning, of list of machine learning algorithms, numpy pandas. So you will get a lot of interview questions uh, in this as well, in this repo. So you guys can go to this repo and you will get a lot of resources, not only the question but the answers associated to it as well. Okay, so I think this is it. Thank you so much everyone for joining in again, and thank you so much Rishikesh sir, for giving your valuable time, and students for like showing this much of enthusiasm. Like so far we are done with like 100 plus chats, and so make sure to share it with the student who might get benefit from it. So thank you so much everyone for joining in. Thank you so much again Rishikesh sir for having us. So
Yeah, my pleasure.
take care. Bye bye everyone.
Thank you. Bye.